Very good evening, sir. Okay, then let's continue. First of all, wishing you a very good evening. It's going to be our sixth session on the aldehyde, ketone, and carboxylic acid. So, let me just quickly give you a brief. In the previous class, we discussed about a beer-Villiger oxidation. There, what we discuss that, for example, you will be having some RCO, R, and if I'm using a kind of per acid, peroxy acid. So what is happening there? That oxygen is going to insert between a CO there. If you are having asymmetrical type of ketone or aldehyde, then we are going to follow the migratory aptitude, right? So these are the topic we already covered there. So let's continue with the next test, that is iodoform test. Since we're discussing about a test like a Fehling solution there or iodoform solution is there, so that one. So let's continue now. In today's class, the topic of discussion is going to be the iodoform test. Okay, iodoform test. As the name suggests, in this case, we are dealing with iodine. Okay, so that's why the name of the test is what? Iodoform test. Second point is what? That in this case, the same thing, substrate and every point. So let's just start that which kind of thing give that iodoform test positive. Make sure this point should be clear for everyone that which kind of reagent we are using. So first of all, the very basic point that we are requiring a methyl ketone here. Okay, so what is the meaning of the methyl ketone? For example, if this is a Cu group, okay, so basically the iodoform test is only for aldehyde, but sorry, only for ketone, but sometime we can go with the aldehyde as well. So for example, this is a CH3. Okay, this is a methyl ketone. Methyl ketone be like next to the Cu group. If the CH3 group have to be there, so it's become methyl ketone. For example, let's just suppose if I'm having CH3 and a CH2 and then CO and then CH2 and CH3 there. For example, let's suppose this is given to us and now it is give the iodoform test positive, so answer is no. Okay, methyl ketone doesn't means like this. Be noted that with the CO, the CH3 group have to be there. Okay, so this is the important point. So let's just see now, that is the CO is there. So now basically what is happening, this is the point number one. But sometime aldehyde also give the test positive. For example, if I'm using acetaldehyde, look at this. So in this case, although this is aldehyde, but still this side we are having a methyl group, so that's why it's going to give the test positive. Okay, this is all for the iodoform test. Next point, that sometime alcohol also give the test positive there. So which kind of alcohol is there? Again, let's suppose this is a carbon, and you can write that as a secondary alcohol. Secondary alcohol give this test positive, except, okay, except ethanol. Like means, wait, that let me just change the statement. Only secondary alcohol give the test positive, give test positive. So which kind of alcohol is not giving the test positive? That is the primary alcohol. And now you trade that except ethanol. So now what is the meaning of this word, that is except ethanol? Okay, first of all, let's discuss about the basic point here. Let's suppose this is a carbon there and this is the OH group. Okay, with respect to this is my CH3 group there. Okay, again, although in this case we are not having methyl, right? Methyl ketone, but how it is give the test positive? Let's just check this. Like why the name is like secondary alcohol give this test positive? In this case, we are using a reagent. Okay, the reagent is what? And I2 and NaOH is there. So this is a mild oxidizing agent. Okay, be noted, it's not very strong oxidizing agent. It is just a mild oxidizing agent. So in this case, if I'm using this I2 and NaOH, so what is happening, that first of all, this alcohol is converted into the aldehyde or ketone. Okay, so for example, in this case, if we are having a kind of alcohol, so we are getting that is a double bond form and it is a CH3 there. Now we are ready with the methyl ketone. But if you are observing the ethanol, although it's a primary alcohol, but still that the primary alcohol will be like ethanol, right? We're talking. So this is ethanol there. It's a CH3 there. In this case, again, that it's a terminal one. And again, if we are using this, so how much we are end up? That is a CH and a CO and OH is there. So this is the basically the reactant we are using in this case. Okay, so that's it. This is all for the point, that how to go with this. So methyl ketone is the basic criteria, and the second one is what? That is the secondary alcohol except the ethanol. So the thing or the substrate will give the test positive. So substrate part is sorted, and next one is the reagent is there. So which kind of reagent we are using? In this case, we are using I2 and NaOH as a reagent basically. Okay, so this is the point number two. And what we are getting, that if let's suppose you are having some methyl ketone, okay, or wait, that is a CH3. So if I'm using some kind of methyl ketone, so basically what is happening in this case, that I2 and NaOH, it is going to convert into the R, CO, and OH is there. It is a kind of acid first point, and this CH is basically converted into the CHI3. It means if in a reaction you want a carboxylic acid from a ketone or aldehyde, and you want one carbon less, so basically just go with the iodoform test. This is the meaning here. Like if you're observing in this case how many carbon is there, that is 1 and 2 carbon, and now how much we are left, that only one carbon there, one carbon release out. So this is how the iodoform reagent is basically working here. Okay, so that's it. This is all for the point. Now that mechanism, right, how it is going to simply that how about the mechanism, how it is going to work. So mechanism is also play a very much important role. So let's just talk about the mechanism of the iodoform test. So let me just write the mechanism part for you. So how about the mechanism here? So in case of mechanism, think about it. We are using NaOH, right? NaOH. NaOH is nothing. It's just a base there, right? For example, if let's suppose this is a CH3, okay. For example, if this is a CH3 and this is a CO and this is a CH3 there. So first of all, this is NaOH. So NaOH is basically a base there. Now, what is the use of this NaOH? NaOH is going to abstract a hydrogen here, okay? So wait, that is this is O negative and it is going to abstract a hydrogen. So as like in this case, there's a tie, you can go with this or this, both, but if this is not mentioned, so every time we are going to go with the methyl one, let that free CH3 group there. So now basically that OH attack here. Okay, let me just write the hydrogen be like that. It is a CH2 and this is hydrogen there. So this OH negative basically attack on a hydrogen. Okay. Now, next point that this form there, that CO and CH2 and negatively charged, right? Now the next one that we are having basically the iodine there. So what is happening? That O negative simply attack on iodine and this I release there. Okay, so means what we are getting basically in this case, it is a CH3 and a CO and a CH2 and iodine. Okay, so this is the point number one. Similarly, again, NaOH came into the picture. Okay, like I have to use two time arrow means the same thing we can follow that NH one time added, one more hydrogen release, or second type NH or added. So this one we are getting. So I'm using NH. Two step means that is we are discussing the last step here. So again, that we are getting CH and a CO and a CHI3, sorry, CI3 there. Okay, so now this is the simple thing that we are getting from the step number one. Okay, so if I have to write the name of the step, so what is the name of the step? Let me just write the statement as well. So the step number two is what? That halogenation of methyl ketone. Okay, so this is a step number one. Let me just write the step number one name. So it's a step number one. What is the name? That hallucination. Hallucination. Point number one, hallucination of methyl ketone. You are basically observing here that is the methyl ketone, the CH3 group simply converted to the iodine part here. So it's a hallucination of the methyl ketone. It's a step number one. Okay, now let's discuss about the step number two. Step number two is what? Formation of iodoform. Okay, step number two is what? That is the formation of iodoform. Okay, so in this case, let me just write that CH3 we are just starting, right? So the CH3 from the previous slide and a CO and a CI3 there. And now in the solution we are left with the OH ion one more time. Okay, so again that OH ion going to attack on this carbon now. Okay, so if this OH attack here, so basically what is happening that OH simply attack here. Okay, this bond open up. Now the next thing that it's a CH3, it's a O negative and it is a CI3 and this is a OH ion. Okay, let me tell you the step, but I want to ask a question for you. Okay, wait. That in this case, this negative charge here and this thing omit. Okay, it means release. It's like behaving like a living group. So means at the end we are just left with it's a CH3 and a double bond and a OH is there. So I guess the point is clear that we are left with the acid. Okay, so although like in the solution you will be having NaOH, so there's a formation of the salt take place. Okay, so most of the time like maybe you are end up with the O negative and an Na there, like sodium salt, simple carboxylic acid salt, and then like how we are end up with the salt. So in this case, this Ci3 negative release, and obviously it's going to abstract the hydrogen from the acid part here, and hence this is how we are end up with the like normally the Cu negative, okay, and plus that is the CHNI3. Okay, I hope this point is clear that now we are left getting a iodoform there. Right. Okay, look at this, that iodoform is ready now. Okay, this is all for the step now. But now a question for you. Okay, in this case, if you are having a CH3 and O negative and a Ci3 and OH is there. Okay, so now my question to you that if this O negative come here, the choice number one, maybe the OH ion can be released. Okay, or the choice number two, that is maybe this release. Let's just tag this is A and this is B. So my question basically is simple for you that A is also there and B is also there. But why only Ci3 release? Okay, don't say ma'am because OH is simply participating here. Okay. Right now I'm only teaching organic chemistry. Okay. Once we're finished, okay, then I can consider other topic as well. Okay. Yes, please. Anyone? Why not? Why not B? Or why only A there? Okay. Yes, please. Anyone doing the reason? Okay, let's consider the basic, like what is the question I want to ask to you here. So for example, that if OH ion release, okay, so if OH ion release, what we are getting O negative ion, the point number one. Okay, the second of what, that is if this is going to release, we are getting Ci negative. So you know that why the reaction is going to happen or why someone is leave the molecule, because definitely after the reaction or after the leaving the molecule, maybe they are stable. You know, we discussed so many times that leaving group tendency is what? That I negative is a very good leaving group over the bromine, okay, over the chlorine and over the fluorine is there, right? I negative, then bromine, and then that chlorine, and then fluorine. What is the reason most of the time? Because carbon iodine bond is not very good, and if iodine has a negative charge, iodine has a large size and easy to handle that negative charge, right? So same here. That now my question for you, like between Ci3 negative and an OH negative, and according to you, which one is more stable? And then you will get your answer. Yes, please, anyone. Which one is more stable here? Okay, so listen here. That is in this case, if you're observing, carbon is connected with three iodine there. It means that this negative charge is really, really very stable because iodine, all three are the electronegative group. So that's why the Ci3 is much more stable with the OH ion and hence it is going to release. Okay, so sometimes this question asked in iodoform test that why not OH ion release, why only the C ion release? Okay, so be noted, it's a kind of question for you, okay, and important as well. That's it. This is all for the iodoform test. Now there's some question like you will tell me which one give the iodoform test positive or not. Okay, so wait. Okay, just which one give the iodoform test positive? It's a A. Okay. Yes, please. Which like A, B, C, or D? Out of all the four option, which one give the iodoform test positive? Okay, one can be correct or more than one option can be correct as well. Yes, anyone? According to you, which give the iodoform test positive? Yes, please. Anyone? Okay, so how to approach the question basically in this question that you have to simply observe the methyl ketone part here. So in this case, methyl ketone, yes, it is give the test positive, yes. The point number two again, in this case, the methyl ketone is there, yes. Is this give the test positive? Yes. In this case, methyl ketone, no, it's not methyl ketone. Okay, ketone, but no, it's not methyl ketone. And hence again option D is the incorrect here. So out of all the option, A and C give the iodoform test positive. This is all for the iodoform test. Now let's start with the very much important, okay, second point. That is the very much important reaction of the organic chemistry after the pinacol rearrangement. That is aldol condensation, okay. So let's just talk about the next reaction, that is aldol condensation. So now what is the meaning of this word aldol? So A for aldehyde, okay, A for aldehyde and O for alcohol. Okay, so basically in this case that like let me just write the substrate. So in this case, which kind of substrate participate in a aldol condensation? So this is really very much important. That is alpha. Okay, wait. That the CO group, carbonyl group. Okay, in the bracket, you have to write it can be ketone or it can be aldehyde. Acid is not going to give the aldol condensation reaction. Okay, so aldehyde or ketone, carbonyl group have at least, be noted, it's very much important key point, that is at least one alpha hydrogen have to be there. Means like which kind of CO bond, that is if this is a CO, so it must have at least one alpha hydrogen. Okay, for example, again, let's just suppose this is a benzaldehyde. If I'm having a kind of benzaldehyde, so be noted, it's not give the aldol condensation test. Why? Or a positive? Why? Because in this case, this don't have any alpha, any alpha kind of hydrogen. Look at this. With respect to this is alpha carbon, and okay, there's a zero hydrogen present here. There's a no alpha hydrogen present. So it means that the substrate carbonyl group, any aldehyde or ketone can be there and have at least one alpha hydrogen. This is the point number one. And how about the reagent? Like which kind of reagent we are using in this reaction? So the reagent wise, we are using a base there. But in this case, we are using diluted NaOH. Okay, it means not very strong base we are requiring say, there. That normal base. Okay, this one. And the second of that Na2CO3. And the third one is what? Barium hydroxide. Most of the time, okay, most of the time you are observing NaOH. Okay, so just be noted. Na2CO3 BaOH twice we can use, but it's not really very much important as the NaOH does. So that's it. This is all for the reagent. Okay, the point number one, reagent there. Now, the third thing that what we are getting. So let's see a general reaction. Okay, let's see a general reaction. So what is happening that you have to start with the kind of aldehyde like ROH. Okay, and we are using this base. Let me just write NaOH, and what we are getting, um, okay, NaOH, what we are getting are CO. Okay, and this is connected. Okay, let me just write this as well like CH2. Okay, because we requiring at least one alpha hydrogen. R is there. Okay, it's a CH2 and R and a carbon R and CONH. So basically, this is a kind of product in this case we are getting. Okay, so what is this? With respect to the CO group, okay, with respect to the CO group, it's alpha position, it's a beta position, right? So what is the final product? That is alpha hydroxy. It's basically the alpha hydroxy carbonyl compound. So we are getting alpha hydroxy carbonyl compound. Okay, what is the name and everything? We just discuss in a while. Okay, so wait. Okay, I hope it's visible now. So basically, this is the general reaction. You'll be having some aldehyde or ketone, and then NH we are using, and this is this kind of product we are end up. And most of the time at that, we are dealing with the hydrolysis step. Okay. So in this case, like okay, this is the final product, but if you are given with this del symbol, it means it's simply representing hydrolysis or heating there. Okay. So if I'm using hydrolysis step, okay, so what is happening in this case? This OH, okay, alpha beta elimination kind of thing going to happen, and at the end you are end up with this kind of product, that is a double bond and a CO NH. So it's a kind of optional step. Okay, it may or may not be there, but it's a fixed step there. And now next point, that the name, right? We discuss about aldol condensation. So A for aldehyde part, that this is the aldehyde part. Wait, I have to highlight. Okay, so this is aldehyde part. Simply this is aldehyde part, and this is a alcohol part. So aldol condensation. If you're using ketone, that become ketol. Okay, so like aldol, aldehyde, ketol. If you're using ketone there. Okay, so this is how the name of the reaction simply there. Now we have to classify the aldol condensation into different part. Okay, so let me just write the like type of the aldol condensation. So let's discuss about the type of aldol condensation. Although like it's the same thing. Okay, but anyway, aldol condensation. So in the aldol condensation part, the point number one, simple aldol condensation. Okay, simple aldol condensation. Second one is the cross aldol condensation. Okay. Third one is the retro aldol condensation. So retro be like opposite simply. Okay. So it's a retro aldol condensation. And the fourth one, simple gross. Okay, intramolecular. Okay. So basically we are having total four type of aldol condensation there. So now let's discuss about all this thing one by one. Okay, different kind of thing. So let's just start with the very first, that is simple aldol. So what is the meaning of the simple aldol? For example, if I'm using one molecule, let's see, let's discuss about the example. So first of all, let's talk about the simple aldol condensation. So what is the meaning of this word simple? Means only one molecule we are having. For example, that if I'm starting with this is my CH3, okay, this is a COH. So it's a one kind of substrate we are using, right? So it's a one kind of substrate we are using. It means only this is the point or the thing which is going to participate. And again, if I'm using NaOH is there, so it's become CH3 and a OH and carbon and one more carbon, CO and hydrogen is there and hydrogen. This is the product we are getting. It's a point number one, simple aldol condensation. But on the other hand, if I'm using two type of molecule means, for example, if I'm using CH, one is this aldehyde, that is the acetaldehyde, plus one more. Let's suppose I'm using CH3 and a CH2 and a CO is there. You know that this is a very basic thing of the chemistry that if you're using unsymmetrical things, so it's a let's say one and two. So in this case, basically we are end up with two type product. Maybe one combined, sorry, four type, one combined, maybe two combined, okay, or maybe one two combined or maybe two one combined. Okay, maybe I hope this point is not very clear for you. Let me tell you the mechanism, then this point should be very clear for you, like what I want to explain to you. So in this case, see, it's a crossing. Maybe one combined with two, maybe two combined with maybe one, and this is two. So what is simple aldol condensation or normally aldol condensation if you're using only one type of molecule, not more than one type of molecule. So let's just discuss about the step basically which we are using in an aldol condensation. Okay, so let's talk about the step or the mechanism there. First, let's just write the steps, okay? Then we're going to discuss the mechanism. So what about the step or mechanism for the aldol condensation? It's very much important addition of the 12th class and really important for the board exam as well, okay? So be noted, it's really important. Okay, so let's start. That is the step number one. Step number one is what? That is formation of enolate ion. Okay, step number one, that is formation of enolate ion. Anyone, can you just tell me what is enolate? So normally enolate ion. Okay, so if you don't know ketone enol form, if you recall, so it's this kind of ion, double bond carbon. Okay, so this type of thing is known as enolate. That keto-enol tautomerism. So enol form enolate ion. Okay, so let's start the step number one. So basically, as we just starting with this acetaldehyde, this. Okay, we're using some NaOH. NaOH is what? NaOH is a base. It means this O negative attack on this hydrogen. Okay, so what we are getting? We are getting it's a CH2 and a double bond and a hydrogen and negative charge here. And obviously in this case we are end up with the resonance there. So it's this O negative simply attack here, this bond open up, and basically we are getting a CH2 and a double bond and a O negative and a hydrogen there. So basically this is our enolate ion. Let me just write. It's an enolate ion. That is step number one. Okay, after once the enolate ion generated, what will be the second step? That is attack. Okay, let me just write the step here and then we're going to discuss with the direction on the next slide there. So the step number two, how about the step number two? That is attack of enolate. Attack of this enolate on another carbonyl. Okay, it's not like I'm using only one molecule. There is a mole we are using, like one mole consists of Avogadro number. You know very well like how many things we're using here. So it's not I'm using only one aldehyde molecule. We're using the number of moles. Okay, so take off the enolate iron, another carbonyl compound. So let's see how. That one more this group, that CH3 and a CO and a hydrogen there, right? Okay, our carbonyl is simply waiting. It's a double bond and a CO negative. Okay, it's a CO negative and this is hydrogen, O negative, and this is hydrogen and this is CH2 there. So see this, that this O negative simply attack here again and this bond attack here. Okay, as you know very well that in this case, this oxygen has a partial negative charge, carbon is a partially positively charged. So basically what is happening, do you know it's a kind of nucleophilic substitution, addition kind of reaction. Look at this is behaving like a nucleophile. Okay, this is behaving like an electrophile here. Okay, why? Because it's a electron deficient center. Let me just back again and now observe this. It's nothing, it's just behaving like a nucleophile only because it's a negatively charged species. Okay, so observe this, it's simply attack here. And then what we are end up there, that is a CH3. Okay. And this bond obviously open up. And this is a CO negative ion. And then the carbon CH and the double bond and a hydrogen there. And this is the point number one. Simply that is a step number two. First step, formation of enolate ion. Second step is the attack of the enolate ion on the another carbonyl compound. Now let's see the step number three. Okay, step number three is what? That is the protonation. Protonation here. Okay, if you're observing, that is formation of aldol. Wait, that is the formation of aldol. Formation of aldol via protonation. So what is the meaning of this word, that is via protonation? That in this case, if you're observing, it's doesn't have any kind of proton, so it's going to extract from what? Water. You know, we are using diluted NaOH there. So this step number two. Okay, sorry, 3. So what is the step number 3? It's a CH3 and a O negative. This is hydrogen simply, and O NH. And this is some water is there, like this. O negative simply attack here. This bond open up, the O negative and release, OH negative and release. And then we are getting, it's a CH3. Don't worry, I will change the position of my video. Okay, I hope it's visible now. Okay, so it's a OH and this is H and this is a CH and a double bond and hydrogen. Now aldol is ready. Okay, so aldol is ready now. This is aldol, that alcohol plus aldehyde. So it's a aldol there. So this is a the thing that we discussed till the aldol formation there. Now what if I have to heat this? Okay, if we have to heat this, that after the heating, the step number four. Okay, so after the heating, what is happening? Nothing. We are going to follow a strict elimination reaction there. So let's see. That is the step number four. If I'm using a kind of heat there or hydrolysis further. Okay, so the step number four. What is the step number four? That is condensation. Condensation. I have to stop this here, and now let me just write the reaction, and you will let me know the mechanism. So it's a OH and a hydrogen, it's a CH and it's a CO, okay, and it is a hydrogen there, right? This is the point we are getting from the previous slide normally. Okay, again that NaOH, the base is still present there. Okay, with respect to this, it's a alpha position. Okay, and it's a beta position, simply alpha beta there. Okay, so in this case, that what is going to happen? Look at this, that beta position, there is a hydrogen present. So let me just write the hydrogen be like this. So this O negative, okay, this OH ion simply attack here. Okay, the point number one, attack here. And then we are just simply add up with CH3. Okay, it is a OH and a hydrogen, and this carbon has a negative charge. Okay, and then CO and H. Simple. And can you just tell me the, okay, this kind, which kind of elimination this is? E1, E2, or even CP mechanism? First of all, base simply abstract the hydrogen, okay, and then in the next step, that we are going to get a elimination product. So anyone, do you know the? type of mechanism? Yes, please, anyone. Okay, so it's an even CB mechanism. Okay, so condensation via even CB mechanism. Okay, so let's see how. O-negative, and remember that the condition for the even CB mechanism, that at beta position hydrogen present, the point number one, and the point number two, that is the beta position is occupied by some electron withdrawing group. If you don't know, please watch the reaction mechanism, then maybe you're getting my point. And then look at this, it's nothing, it's electron withdrawing group, right? It's electron withdrawing group and beta hydrogen, and obviously it's a even CB mechanism. Okay then. So next point, that this O simply attack here. Okay, and this oxygen abstract the hydrogen from here, and then this is be like and water molecule remove simply. Okay, so let me tell you that how the positive simply release. Okay, and then we are getting, it's a CH3 and carbon double bond, and this is a CO and H is there. So this is the final product we are getting. Okay, last product. So total three step mainly, but if heat is there, so you have to go with the step number four as well. That is the condensation step, or the condensation via even CB mechanism. This is all for the aldol condensation basic mechanism. Okay, now your turn. Any problem with the mechanism? First of all, let me know. Yes, please. Anyone, any kind of doubt? Okay, then. So I'm considering that you are not going to ask anything. So let's see. Then let's proceed further. Okay, so done. Now okay, this is all for the reaction. Who is going to remember that mechanism? So let's discuss about a normal soldering. Okay, so let's suppose that I'm having some R CH2. Okay, this is some CO and hydrogen. You have to write the same molecule on the other side. That is again, it's a R and a CH2 and a CO and hydrogen. Okay, so whatever be the CO there, okay, so for example this is my CO, so you have to consider the CO of the one molecule, first point, and the hydrogen, the CH2 group of the second molecule, combine them. I'm repeating one more time that you have to consider one CO one molecule CO bond, okay, and one molecule the CH2, that next alpha carbon one, okay, and then combine them. So let me just write that is, this is CO, okay, so like O, and this is hydrogen, and it is a CH2, and this is some R. Okay, simply. And then this is a CH2 because we are combining this R CO double bond. Okay, sorted. And for which we are using a carbon double bond, definitely it is going to end up into the alcohol there. Okay, you know the basic step that now this attack here, this bond open up. So this is basically the OH ion now. Okay, so this is how you to join, for which molecule we are using a CO bond there, for that one, that OH group form. Okay, this is how simply connect them. And the next step, that hydrolysis. So simply hydrolyze the water molecule, like remove the water molecule. So what we are end up with, that the carbon double bond and a CO and H. So this is how you have to apply the trick. If you don't know the mechanism, it's one of the easy reaction of the organic chemistry. Okay, so I hope it is clear for everyone. And again, if it is not clear, please let me know. Okay, so now let's solve a question. Okay, so let's try to solve a question. Just answer the question. Okay, so I'm starting with this simple molecule. This is a a kind of high membrane and a diluted NaOH. Okay, there's a some X form and the step number two, right? So it's a heat NH positive, simply the hydrolysis step, and then you are end up with some Y. You have to identify the Y. Okay, so what is the question? That is the find Y. So how about the options there? Okay, so option number one. Okay, this is the option number one. Option number B. This is the option number B, okay? And please tell the near to solve. I had to write the options. And this is the option number D, okay? Yes, please. Which of the following is the correct answer here? Like A, B, C, or D? Yes, please.